Hi, and welcome to my talk. My name is Michael Price. I am the C++ Developer Cloud Tooling Product Manager at Microsoft. And you're here for my talk today, GitHub features every C++ developer should know. So, I'd like to preface real quick and say that not much of this talk is C++ specific. It's not about C++, but every C++ developer has problems, right? We know that they have these certain problems from surveys and things. So this content should be relevant for everyone in the room, especially if you're a current GitHub user, but even if you aren't an active GitHub user. Okay, I have a few front matter slides to get through. We're already at the end of the conference, but we're still welcoming people to CppCon this year. There's still a lot of sessions today. We hope you enjoy your time in those sessions. If you have any questions about Microsoft products here at the conference, you can find us in the Visual Studio channel in Discord. If you're having trouble finding that, you need to go to the directory channel in Discord, and it has instructions on how to join the special interest group channels from there. And then secondly, every year at CppCon, we run a survey to get sort of the pulse of the C++ community. We do something at Microsoft now called customer-driven engineering, where we put the customers front. Right? So in order to make decisions about what our products are doing, we need to hear from customers, right? So it's very important for us, for people to fill out this survey, give us their feedback so we know that we're going in the right directions. And then the last bit of front material, Microsoft employees had a lot of sessions at this conference. We're on the last day here. We have 3 sessions today. There's mine now. Directly after this, 15 minutes after this, in the same online track, we'll have a Visual Studio 2022 talk. And then later in the evening, our very own Herb Sutter will be giving the closing keynote on C++ complexity. So I'm going to jump in, and we're going to talk about some things that we know about C++ users from data we've collected or survey information that we've observed. So this chart shows the most popular languages in GitHub every year since 2014 and how they've trended over time. Some of the other languages are hard to see because they're very dimmed out, but that blue line is C++ and the green line is C. So C and C++, we know from the data in GitHub repositories, are very popular languages on github.com. And they have been for as long as GitHub has been around. Right? There are definitely more popular languages in the system, but these continually rank in the top 10. And it's sort of remarkable, right? Because C and C++ are considerably older than all of these other languages. They've been around oftentimes decades longer than the other languages on here. And so the lasting power of C and C++ is pretty amazing. And the other interesting thing to note here is that C and C++ are the only ISO standard languages on this chart. And so, in addition to that information, every year the ISO C++ Foundation does a survey. And they ask questions about what kind of pain points people have, what kind of editors they're using, a whole set of questions. So I want to walk through some of the results that come out of that survey this past year. So, from the survey, 57% of C++ users are using Visual Studio or Visual Studio Code as their primary editor. Right? We love to see it at Microsoft. We love it when people use our products. We love it when they're successful with our products. And, in fact, during the conference, we have 2 sessions, one on Visual Studio and one on Visual Studio Code, that tell you about all the new features, the great new features in those products. We also know that the biggest pain point every year in the survey is C++ users say they have problems managing their library dependencies for their projects. In fact, 83% of C++ users indicate that this is a pain point for them, the highest of any of them by far. Well, we also had a talk earlier this week on that. C++ dependencies don't have to be painful. We talked about the general problems and how we can solve them, and we also demoed some of our solutions with VC Package, which is our package manager that we produced. Also, 75% of users say that setting up CI, continuous integration from scratch, is a pain point for them. Also a very high number. Well, that's part of this talk. And 71% of users say that setting up a new development environment is a pain point. That is covered by this talk and a talk that I did yesterday earlier in the conference, Reproducible Developer Environments. I really encourage anybody that's seeing this video, if you're interested in any of those topics, to go please find the videos for these talks that were earlier in the conference. Hopefully you'll get something valuable out of them. And then lastly, we have 2 pieces of information from the survey that are important to me. 47% of users say that they're using cloud services and infrastructure for continuous integration or continuous deployment. That's a pretty high number, right? I'm glad that lots of people are using cloud services to do that. But we also see that 40% of users say they're not using the cloud in any way whatsoever. And that's a pretty drastic bifurcation of the community, right? And so as the developer cloud tooling product manager, I am interested in why this is the case, right? So if you are in either of these groups, right, I would be very interested in talking to you about why you've decided how to use the cloud or not. So please get in touch with me later. I'd love to talk to you. Okay, so automation. So we're going to talk about things that you might want to do and then how GitHub can solve those. So we want to automate things. We want our builds to be automated. We want to produce artifacts. We want to deploy in an automated way. So let's talk about how GitHub solves automation. So the solution for automation in GitHub is GitHub Actions. So we're going to talk about 5 terms or concepts with GitHub Actions that you need to understand in order to be able to navigate documentation and anything written about GitHub Actions. Okay, we're going to go in order here. Workflows. So a workflow is sort of like the top level entry point into GitHub Actions. It is a process that runs one or more jobs. We'll talk about jobs in a minute. It's defined in a YAML file that's stored in your repository and versioned with your repository. You can trigger a workflow manually or on some sort of schedule, like a cron job would be, or by some event that happens in your GitHub repository. You can reuse workflows. The reuse is somewhat limited, and it kind of makes sense. You might want to reuse workflows inside your organization, but they may not make sense to be used outside of the org, but you can reuse them. And if you're interested in getting started, there are already pre-baked templates for starter workflows that you can go and find, and we'll see the use of that in the demo. So I mentioned that workflows can be triggered by events. So what are these events? There are lots of events. There are well over 100 different events that you can use, that you can hook into to trigger your GitHub Actions workflows. So there are obvious ones like pushing to branches, creating a pull, pushing changes up to a branch that is a pull request, closing a pull request. But you can also set actions on things like when issues are opened and closed, or if somebody adds a discussion item in your GitHub discussions area. Even so much as like if someone goes and clicks the star to watch or star your repository, you can actually set up actions to watch that event and track that data. Okay, so workflows run one or more jobs. So what are jobs? A job is a set of ordered steps that execute on a runner, right? Jobs, you can have multiple jobs in a workflow, and by default they run in parallel, right? But you can actually set up a dependency graph between the jobs. The important thing to know about the jobs is that each job runs on its own runner, right? Its own execution environment. So if you need to share data, maybe you produced some files that you want to, some binaries you want to run, you might want to do that within a job. Otherwise, you need to have some sort of way to, there are ways that you can pass information between the jobs, but it might just make sense to do it all in the same job. Okay, now actions. Now the name of the feature is GitHub Actions, and we haven't really talked about actions yet. We've talked about these other things. So what are actions? So I mentioned that jobs basically have an ordered set of steps. A step can be a run step that just like runs some sort of command, or it can be a uses step, which uses an action. And an action is just a reusable step component. You can put these in your org, in your single repository, or you can actually publish them out on the GitHub marketplace for other people to consume. And it's a really convenient way to avoid having to do a lot of heavy lifting in your own workflow if you just use someone else's action. And then finally, runners. So a runner is the execution environment for a job, okay? And GitHub offers runners in their cloud environment, so you don't have to manage that infrastructure yourself. And they can run on Ubuntu Linux, Microsoft Windows, or Apple Mac OS. But there's also a self-hosted runner capability where you can download a runner agent to any machine that you want with some caveats, and actually get it hooked into the GitHub Actions system that way. Okay, let me take a quick sip of water. So we're going to talk about the runners, because ultimately the runners is where the cost for GitHub Actions comes into play. So the standard GitHub hosted runners that are offered, Linux, Windows, and Mac, they're pretty low powered, right? They have a couple of cores, they have some RAM, the hard disk spaces, yeah, okay. But they're also very cheap, right? So for example, the standard Linux runner is less than 1 cent per minute, right? So you pay for computation time, but you're also paying for storage too, right? So if you have this 14 gigs, there's a rate you consume for that as well. I also have this column here that's in pink that has these multiplication factors. I'll be coming back to that in a minute. And so if you are a GitHub user currently, depending on what plan you're on, you get free stuff here, right? So if you're just a hobbyist and you've got a project and maybe it compiles, maybe you get a push or something once a day, there's a very good chance that you might be able to have your CI system and it doesn't cost anything, right? Obviously, if you've got lots of engineers making lots of pushes and you're doing lots of runs of workflows, well then that's gonna build up. And if you have, say, like Enterprise Cloud plan, you get a whole lot of stuff for free just with that plan. However, also, GitHub started a beta for larger GitHub runners. And so if your plan is on the team or enterprise cloud plans, then you have access to larger GitHub hosted runners. And there's a particular way in which you can opt in to doing these. But you can get pretty large machines with these, up to 64 cores and 256 gigabytes of RAM, and much larger hard disks. But correspondingly, they cost more to use, right? But if it turns out that you can cut down your execution time by that, man, you might actually be saving money by going with a larger runner. And so here's where I want to call out the pink, right? So when it comes to calculating your usage for the purposes of how many free minutes you've used in things, these multiplication factors are what you would look at. So every 1 minute on this base Linux system is equal to, every 1 minute on the Windows 64 core system is equal to 64 minutes on the base Linux system, right? So you need to take that into account if you're planning on doing using your free allocation. And then finally, with the self-hosted runners, this is the list that they have in the documentation of the different platforms that it runs on. In theory, if the runner application runs on your system, it probably will work. These are just what are documented to be supported. Okay, so I'm going to shift gears from automation and GitHub Actions to developer environments. So I had a talk yesterday about this entire topic, but we're going to cover GitHub Codespaces here. Before we get to Codespaces, there are a couple of other products that are related to Codespaces that are different and similar but different in other ways. So I want to talk about VSCode.dev and GitHub.dev. So these are both Visual Studio Code instances running in your browser. It's a full VS Code, right? It's just running in your browser. Here's a chart of the things that they can do. So the real difference there's a lot of questions I've seen, and I've had questions too about, well, what should I use, VSCode.dev or GitHub.dev? What does one get me over the other? Well, the big difference is that VSCode.dev is more general purpose, right? So you can actually connect to GitHub repos, but you can also connect to Azure repos. You can actually connect to files that are on your local file system directly from vscode.dev. And there's lots of potential for other routes that you could load up in vscode.dev. GitHub.dev, on the other hand, is very particular to GitHub-hosted repositories. And they've made that integration very, very smooth, to the point where all you need to do is change github.com to github.dev, or even just press the dot or the period key on your keyboard when you're in your github.com repository webpage. That will just load up Visual Studio Code. It'll even put you on the same branch that you have active in the web page. It's pretty great. But both of these have a problem. These are Visual Studio Code instances running in the browser, so they are limited to the things that a browser can do. Well, it turns out that there's lots of extensions that aren't able to run in that environment, including the C and C++ extensions, because you actually have to compile, produce files. It's very intensive, right? So if you want to do those types of things beyond just maybe web programming or manipulating Git, right, then you actually need something with stronger compute power. And that's where GitHub Codespaces come in. So GitHub Codespaces are on-demand, container-based cloud development environments. Their state persists, so if you disconnect and have to connect later, it brings you exactly back to right where you were. Whenever you create a code space, you pick what kind of SKU, what kind of hardware resources you want, and there actually is limited ability to migrate between SKUs. So if you make a code space that's 2-core, and then you later decide that you want a 4-core device, there's actually ability to sort of like lift your container out of that and put it onto a beefier machine so you get more resources. I'm hoping that eventually they make this a little actually more flexible. That would be really handy. Like if you are doing something that's intense, but then you want to shift to something that's not intense, you can actually save money by doing that, perhaps. The real power for these comes from the dev containers that are used to configure them. The dev containers that they use is actually a specification that's on GitHub that was created by Microsoft, but it's an open source specification. And there's actually a reference command line tool implementation that you can use outside of Codespaces. If you wanted to use it locally, you could actually run these containers on your own systems. And in fact, Visual Studio Code and Visual Studio both support dev containers outside of the context of GitHub Codespaces. Right now, both of those are only support Linux containers. We don't have Windows container support yet, but this is an area that we're interested in. And because this is built on top of Docker, whenever you first create a container, it can take a dozen or so minutes if your Docker image is complicated, has lots of layers. So GitHub has the ability that you can actually pre-build your containers, your underlying containers, with GitHub Actions, so that whenever your users go to create a code space, it just spins up in a matter of seconds instead of taking dozens of minutes. Okay, collaboration. So GitHub's all about collaboration, right? But we're gonna take a brief history detour because I often find that people have a conceptual model that the conceptual model of Git doesn't really work with them that well because it's different than other traditional source control tools. So we're going to talk to them about that. So GitHub was obviously sort of founded on top of the foundation of Git, right? So then we need to ask, well, okay, what was the origin of Git? What were the constraints and requirements that went into the development of Git? Well, it was Linux. Git was born out of the Linux development process. We'll talk about that a little bit more in a second. And well, Linux, of course, is built on top of Unix and C, right? So if you really want to trace the history to it, GitHub actually exists because of the Unix and C ecosystem. Right, so it's not a big surprise, honestly, that C and C++ would be very popular languages in GitHub. Okay, so this is a quote from Linus, the creator of the Linux kernel. Git was obviously designed for the Linux development workflow. So Git was basically designed and written for my requirements, and it shows. So what were their requirements? So the Linux development workflow was very decentralized. People had their own copies of the Linux kernel code. They would make changes, and they would send patch files to Linus or whoever the maintainer was, who would then look at them and provide comments and review them. And if they thought they were acceptable, they would integrate them into the source of truth repository for Linux, if there is a source of truth for it. And so those requirements are what sort of drove the development of Git. And so Git uses a pull model of collaboration, whereas most other source control tools used a push model. And a push model, the person who's pushing is sort of authorized, and they know the best. They will push to this thing because now that's the source of truth. But the pull model is different. And GitHub actually combines these two things with GitHub forks. Right? So you're still using the pull model, but you can create your own cloud copy of the source code instead of necessarily having it locally, which you may still do, that you can push to. And the combination of those two things is often the thing that causes people conceptual problems, right? You have to both push and pull, right? Okay, so GitHub, is very big on collaboration, and there's three features here that they have for that. One is GitHub issues. This is your defect tracking. If people have problems, they can file issues with your repository. You can decompose issues. You can apply labels, and as we saw earlier, they're automatable with GitHub Actions. Projects. Projects is your long-term planning for your project. It's very flexible. They actually released a new version of projects in the past month or so. And it's just like a table-based sort of system. So you can adapt it to whatever your needs are. We'll see an example of this hopefully at the end of the talk. And then pull requests. Pull requests is the main model by which code gets filtered into other repositories from someone that wants to make a change. It's also where code reviews happen. They're automated, so you can make gated merges. You can make sure things pass before they make it into the repository, the destination. It's an access control method, and they're also automatable. And we're going to demonstrate this. Pull requests and issues actually has an extension in Visual Studio Code that we'll be taking a look at during the demo. Okay, I'm a couple of minutes behind, but we're going to do a demonstration. All right, is my mouse working? Nope. Okay. So, for the demonstration, what we're going to be doing is we're going to be working on a project that has no CI system at all. In fact, it's a project that I resuscitated from something I did over 10 years ago, when we didn't know better that things needed CI, right? And what it is, it's an implementation in C++ of the classic board game Go, right? So in the board game Go, players take turns placing these stones down on grid points on the board. And what your aim is to surround another opponent's set of stones with stones of your colors. And if you completely surround them, you've captured those stones. And at the end of the game, whoever has captured the most stones of the opponent is the winner. So we're going to add this and look at some PR issues and stuff, all without ever leaving the browser. Okay. So we're going to look at, here it is right here. So I'm going to go ahead and spin up a code space for later. Okay, it's already been spun up and it's connected. I'm going to come back to that in a minute. So the first thing that I want to do is I want to actually create an action for my CI. So I'm on my main branch, which is where I want to be. I'm going to go to Actions. Okay, this is the starter workflow area. I'm going to type in, it's a CMake based thing. Okay, we're going to do that search, if it will actually search, CMake based projects configure. This is going to instantiate the starter workflow in my repository, drop me right into an editor. Now, this by default is not a multi-platform starter workflow, and so I've already gotten code that I want for this over here. I'm just going to copy and paste that into here. Nope, that's not right. No, I don't want to do Control A apparently. There we go. Okay. And I'm gonna change the name there, and I'm gonna start the commit. Sure, that commit message is good. Okay. Now I'm gonna go ahead and trigger this workflow. So if I go to the YAML file, I can access the workflow runs from View Runs. And you can see here, there's a Run Workflow button here. Okay, I'm going to run that workflow, go ahead and get it started. Now I'm going to go ahead and add another workflow for the Microsoft C++ code scanning tool. So, just going to say Microsoft C++ code analysis. That's the one I want. Same thing, it isn't quite formatted like I want. So I'm going to just copy this other code that I have. Well, keep selecting more than I want. There we go. Okay. We're going to go through the actual contents of this in a few minutes. I'm going to start that commit, and I'm going to do the same thing. I'm going to go ahead and trigger that workflow. Okay. So those are off in the background running. They'll take a few minutes, which is why I started them now. So I want to go back to the YAML file from this workflow run. It's really easy to get back to the YAML file that supports this. If you find the ellipsis control here, there's a view workflow file that was the workflow file that supported this. Okay. I'm going to increase the font size so people can see a little better. All right. So there are a few things I want to call out in this YAML file. The first thing is the trigger event. That's this on setting. So workflow dispatch is the event that is, this thing is callable from other workflows, but it also happens to be the thing that creates a manual trigger as well. So if you want a manual, that's what you do. The next thing to call out is the runs on. So this says, what is this job going to run on? This happens to be using a matrix OS. This is what's called a GitHub workflow expression. It's how you can sort of substitute variables into pieces of the workflow. And what this is referencing is a thing called a matrix context, which we'll see down in this strategy area. So what this is saying is that for all of the values in this array, we're going to run on each one of those. So that's actually going to spin up multiple jobs for each of those. And it's going to run on that operating system. Actually, it's a tag for a type of runner. In addition, what a matrix job gets you is the ability to set other variables, and it actually constructs a matrix of these different build configurations. So there will actually be 6 different builds, 6 different jobs that will run because of this. So then let's look at some of the steps here. So we'll use an action to check out the source code. We're going to use an action from one of our community members to actually set up Ninja on this system. And then we're just going to run VC package install directly. There's actually an action you can use here too, but I wanted to show a step, and this is simple enough to demonstrate that. And then we're going to configure and run CMake, and it's going to configure, build, and run the tests. This is an action produced by one of our Microsoft engineers, Luca, that runs CMake. And in here, I'm actually providing some environment variables for this particular action to use. These just kind of smooth out some platform differences so that it can run correctly. Then after that runs, I'm going to use another action to generate test report. So my C-test is actually producing JUnit formatted output. So I'm basically telling this test report action to consume that and produce pretty results in the results. Okay, so let's look at the status of things. Okay, some of the things are still running, but we have enough that we can actually get started looking at stuff. So let's look at Ubuntu latest debug. Okay, so you can see in the run for this, all of the steps that were in my YAML file are these collapsible things. So you don't get a whole bunch of output that you have to then go find, okay, well, I want this section, right? If you want to look, say, into one, you can uncollapse it. And then even inside that, you may have collapsed sections to be able to find things. And luckily enough, this action actually gives you a report of how long each one of those sub-steps took. So example, if we wanted to look at the generation, we can see all of the CMake output that happened during the generation. And then what I also want to look at are these others. So I said there would be 6 jobs, but it looks like there are more than 6 jobs in here. Well, the test reporter action actually produces these fake jobs as a part of its work, right? So if we look at that, you can see we get a nice pretty output of all the tests that ran with a report, and then we also get more detailed information further down below it. So if there were any test failures, we would have seen this, and instead of being a green check mark, it would have been something else to indicate that there was a failure. Okay, we're going to look at the analysis now. Let's see, did it finish running? Okay, it did finish running, but we're going to go look at the actual YAML file. Okay, so very similar. There's only a couple of things that are different. There are some additional settings in here that you don't need to pay attention to at the moment. This is only running on Windows because it only runs on Windows. It's using the Microsoft C++ analysis tools, but it is running debug and release. It checks out the code. It only configures CMake because we don't need to actually build CMake and run the tests in order to do the step. We just need to have it configured, saved on time. Then we reuse the Microsoft MSVC code analysis action. And this commit hash out here is actually just pinning it to a very particular version of this that has been published, so that if it changes, we don't have to worry about dealing with those changes. We give it the CMake build directory, and we're just telling it to run with the native recommended rules. If you have your own rule sets, you can actually specify that so it behaves, produces different results. After that, we're going to upload the result file called a serif file to GitHub, and we're going to see where that comes in a second. But we also upload it as an artifact to our job run as well if you want to download it and view it in some other tool. So let's look real quickly at the code scanning alerts. So because this is hooked into GitHub's code scanning infrastructure, what you'll now see is up in the security tab, there's this indicator that there are 3 issues there now. So let's see, what did it find? Okay, so this is saying, okay, we ran this code analysis, there were 3 alerts, and these are the 3 alerts that it found in my code. So a couple of them are dealing with casting between integer types, that something is not quite right there. I'm kind of interested in this uninitialized member variable, though. We don't really want uninitialized member variables that can cause bugs. So I'm going to drill down into that and see what it's telling me. So it very helpfully tells us where in the source code it found this at, and it's basically saying that this player type, the constructor for this player template type, has a mStone color, but it is not being initialized, right? And so, I remember at some point in time in the past, I had some issues with stone color, this enum type, and I think that it's probably related to this. So what I'm going to do is I'm going to go look at the code. Okay, yeah, there's an issue that I filed. It happens to be last night, but that there's something weird with stone color. There's none value enum that uses a sentinel value to indicate there's no stone on a particular point. That seems kind of weird, right? So we're going to go fix that. So in order to fix that, we're going to use a Codespace. So I already have the Codespace spun up. Don't have to wait for it to spin up. And here it is. So I just want to point out here, there's a GitHub extension that's already loaded into the Codespace. You don't have to go load it up. And you can actually find issues directly in here. Hopefully this is actually loaded. Okay, that's not what I want. I'm going to refresh this. Okay, it looked like it was still connected, but it wasn't. We're going to let this connect. So what I was going to show there is that the issues plugin, actually you can see the issues that are filed directly in here. And hopefully it loads up soon. 25 minutes. And we're going to let it load. Oh boy, boy, it's taking a long time. Gotta love conference Wi-Fi, right? Okay. Okay, it's working now. Okay, here we go, finally. All right, so you can see in created issues, there's my issue. Now it doesn't load up in the UI here, but you can go to the web page for the issue right there. So we know there's this issue. I want to fix it. So what I'm going to do then is I'm going to create a branch through here. I'm going to call it Fix Stones. Oh, it checked out the wrong one. I need to go back to main, and then I need to check out Fix Stones, create new branch. Okay, so I'm on my new branch here, and the first thing I'm gonna do is I'm gonna go change my YAML files, and it doesn't look like I'm actually on the right branch. Oh boy, it should have. Okay. This is frustrating. Apologies. Okay. This doesn't seem to be loading up the right branch information. So what I'm going to do instead is I'm going to do it through here. So I'm going to make a new branch. Okay. I'm going to go in here and I'm going to modify these files to also do, oh, I got to actually edit it. Pull request. So anytime that a change is pushed to a branch that is on a pull request, then this thing will actually run. I'm going to do the same thing to msvc.yaml. Okay, and save that. Okay. Let's go back and see if this has come back alive. It hasn't. Okay. What about this? Okay, well that is sort of disappointing. All right, so we're just gonna continue and going through. We do need the code space to do the compilation though. Okay, so what I'm going to do instead is I'm going to show a video of this that I pre-recorded before. I just have to get it keyed up to the right point in the video.
All right, so those have been pushed. Now I'm going to go make my pull request. I'm going to do that for pull request gets new commits, or when a pull request is.
So you can see this is the change that I just did in the GitHub UI.
All right, so those have been pushed. Now I'm going to go make my pull request. I'm going to do that from the GitHub extension as well. So I'm going to say create pull request. Okay, I'm going to go from fix stones into main. And I'm going to say fix issues with stone color, none, and initialization. Say this should fix issue number 1. Okay, those are the 2 changes in it. Create. Okay, so I've created my pull request now. Now the really neat thing is that I get to see the pull request UI directly in Visual Studio Code. I don't have to go back out to the GitHub web UI to see things. You can see, let me do a refresh. I already have 8 pending checks. So it even shows me the workflow, the GitHub Actions results, the workflows that get triggered in here as well. There are 8 because 6 of them are going to be our build and test, and 2 of them are our analysis. So I'm going to go ahead and just let those run with just with no other changes to the code or anything. And instead of, I'm not going to walk you through the actual changes I'm making to fix the issue, but I already have all this work over in another branch. So, okay. So, I have things over in another branch, and what I want to do is cherry pick those changes into the branch that I am working on here. But in order to do a cherry pick that way, I really need to get a terminal window, and unfortunately, terminal windows are not so.
I'm going to pause it here. So when I did this recording, I was actually working in GitHub.dev for this portion of it. And so in a second here, I'm going to be moving into a Codespace.
Recorded in GitHub.dev. And it makes sense because there's no actual computer back behind this, right? This Visual Studio Code instance is just running in my browser. There's no virtual machine or system back there behind it. And, these are code changes, right? It'd be a good idea to test these locally, compile them and run the tests and stuff before I push them up, just to make sure, I'm not, pushing changes that I could otherwise know are going to fail. So we can no longer work in GitHub.dev to satisfy all those. So instead, what we're going to do is we're going to create a Codespace. And that will get us an actual virtual machine to work with. So there's a couple of ways to do that. Directly from GitHub.dev, all I really have to do is click this here. This is the GitHub remote repository. If I click that, there's a continue working on. If I do continue working on, it gives me an option to create a new Codespace. I'm not going to do that here because creating a Codespace can take a few minutes to spin up, and in the interest of making this go faster, I've already spun one up. In fact, I'm going to restart it here. Okay. The other way to do this is if you open up the command palette with Command or Control-Shift-P or Command-Shift-P if you're on a Mac. You can do Codespaces connect Codespace. And what this does is instead of creating one, it just lets you connect to one that you've already got going. I've already got it loaded up over here, so I'm not going to do that either. So just for the meantime, I'm just going to send this guy back out of there. Close that. Okay. So I've got my Codespace up. I'm just going to check and make sure that the GitHub pull request is still what I expect it to be. Quick description. Yep. We can already see some of my CI, some of my workflows are completing, and the tests are running and being reported. That's great. Okay. So let's go cherry pick some stuff. So what I'm going to do from here is I'm going to go to my terminal, and I'm just going to do git cherry pick. I'm going to give it the name, a GitHub ref ID, which is just going to be the name of my branch that I have my fix in. Oh, I'm in the wrong branch. This would be normally this would be check out name git cherry. Okay, that would not be a part of the thing. I'm in my main branch. I'm going to check out. I have to fetch. Check out my topic branch that I'm working on. Now I'm going to go apply my cherry pick here. Okay, so if I look at the log, I can see that, I've got trigger is there, and I just cherry picked this remove stone color none. Okay, that's the change that I want. Okay, so I've now got this on my branch. locally. So I'm going to build. Let's see what happens. Okay, it's a pretty short build. That all worked pretty well. Okay, so let's see. Tests. Let's select the debug test preset and run ctest, and it looks like all tests pass. And just for good measure, we're going to run the product. We're going to run it. So let's say I'm player 1, and I'm going to play against Whopper, and I'm going to do 0. So, as a demonstration of what this looks like in the game, I'll show you what a capture looks like. So I'm going to go 0, 0. So put a black piece there. So what Whopper wants to do is surround that piece, right? So they're going to do 0, 1, and then I'm going to do like 2, 2, and then they're going to do 1, 0. And when they do that, what's going to happen is there's not going to be any orthogonal pieces all the orthogonal spaces are going to be taken by the other stone color. So they're going to end up capturing my black stone. And the game proceeds like that until we're done. Okay, great. So I think that shows that all worked. I would say too, a lot of the stuff I just showed you here with building and running, we have a great Visual Studio Code talk that's going to happen. It's going to be an online only talk.
Okay. So that was a demonstration of how the Codespace works. I really wish my local system here would have been able to show me. I would have been able to show it live, but that's why I had the backup recording. So the last thing I want to talk about with GitHub is its sort of ethos about working in the open, invisible, and as a part of sort of an open source infrastructure. So, GitHub does a lot of stuff in public, right? If you have an issue with GitHub, you can easily file issues or discussions with them in the GitHub community. If you go to github.com/orgs community, this is where you can interact directly with GitHub employees using GitHub to answer questions about if something's not working right or if you're having trouble with something. You can get in touch with people there. And oftentimes people that are not GitHub employees might be offered to help as well. One thing I want to call out is that GitHub is using their project system for what's called the GitHub Public Roadmap. So you can access that. It's not an intuitive URL, but github.com/orgs/github/projects/4247. This is the GitHub Public Roadmap. So you can see what it is that GitHub is planning on releasing this quarter, the next quarter, what they've already released. And you can also get experience with what their project's product feature looks like as well. You can only filter to the GitHub versions that you're interested in. Like if you're an enterprise, like an enterprise server user where you have your own locally hosted GitHub Enterprise, you can filter it down to just the features that show up there. Or if you have specific features like Codespaces that you're interested in, you can filter down just to view the features that they're releasing related to that. It's really handy. People should really know about that because it helps you plan your stuff and how you're going to build on top of GitHub. Okay, so that's the end of most of the content here. Enjoy the rest of the conference. Again, you can find us on Discord, and I highly encourage everyone to take the CppCon survey that we put out. Again, I really can't stress it enough. We want to hear your input, even if you're not a Visual Studio user. In fact, maybe especially if you're not a Microsoft products user. We want to hear you, right? We want to make C++ better for everyone, not just the people who use our products. I think I'd like to start off with any online questions. Maybe we could take 2 of those and then see if there are any in-person questions.
Are GitHub Actions any good for benchmarking and monitoring performance regressions? Can we say select a particular CPU microarchitecture or make sure that there are no noisy neighbors on the physical machine?
Right. So as I understand it, the question is about performance regression on actual machines instead of virtual machines. So yeah, you can actually, if you have your self-hosted runner, right, you can choose to run these things on real physical machines if you want to. And while you have some overhead of the GitHub Actions runner installed, it shouldn't be that significant. And so, you can control the environment that the runners are executing in, or that the jobs are executing in, if that's something that your situation needs. Right, so the question is, are the self-hosted runners available on any GitHub plan, or do you have to have a team or enterprise plan? I think the answer there is that yes, that they're available to anyone. I'm not certain though. That's something I can check. If you want to follow up with me, I can check for sure. Yeah, it should be pretty easy to check. They have pretty good documentation on how to set up the self-hosted runners. So obviously you can try it and see what happens. If it doesn't work, it would be pretty obvious as soon as you run the runner and it tries to connect, it will probably like complain, right?